So this would be, if you were out, what we're going to learn on Friday, so February 16th. This is the third day of multiplying and dividing integers. It's the last day of new material on multiplying and dividing integers, but we'll have some review days as well next week after our nice long weekend, which hopefully will get everybody nice and healthy. So if you're going to be out Friday, if you already know you're going to be out, or if you're watching this over the weekend and you were out, here's your notes for this. Again, you're probably going to want out a sheet of paper, something to take down some notes with, because here you have some vocab. So the last thing we want to learn in this section is how to find some statistical data. You might remember seeing a question on your EM Power test asking you, is this a statistical question or not? And I know a lot of you guys asked me, what does that mean? And I explained as best I could without giving things away too much. But stats is like the short for it. Statistical data can be collected anytime you have a lot of numerical data. You guys would probably see stats a lot in sports. So, if a player is coming up to the line at a basketball game to shoot free throws, it might say this player is a 75% free throw shooter. Well, that number is being derived from how many shots that person has made versus how many shots they've attempted, they've tried. So that's an example of a stat. You guys have your own stats, which we'll talk about in just a second here. There's lots of different types of stats you can calculate about a collection of data. One of those things is a mean. You might also know that as an average. That's probably the word you're more familiar with. So right here it says also known as the average. Okay, so the mean or the average, the way you find it is it's the sum, remember means adding, of all the data. And then once you get that sum, you divide by the number of pieces of data you have, okay? So an average you guys would probably be familiar with about yourselves would be your GPA. You guys can see that on Skyward. GPA stands for grade point average, and how that's calculated is they take all your letter grades, they turn them into numbers between 0 and 4. They add them all up, they divide by how many grades you had, and that's how they come up with that number. That's somewhere, in the 2s or 3s or 4s with a decimal at the end. And that gives an average of what grade you're getting. So then if you turn that number back into a letter, that tells you, okay, on average, this person's an A- student, or this person's a C+ student, okay? So that's an average you guys know. In baseball, batting average. So every person that comes up to bat, they'll show their batting average. They show it as a decimal. It's usually a decimal, it's always going to be less than 1. But the closer it is to 1, the better batter that person is. And that's, again, calculated by adding up their data and dividing. So we have an example here. You could also get an average when I give you guys a test. Once I've entered in all those grades, I can see what your class average is. So on average, first period scored this on the Chapter 6 test. The way I get that is I add up all your scores and divide by how many people took the test. So in first period, we have 28 kids, so I would divide by 28. In fourth period, we have 17 kids, so I would divide by 17. So here we have an example of just an individual student and wanting to figure out what his average is. So we have Sam had math test scores of 55, 60, and 35. His mean, his average, we would get by adding these 3 test scores together and then dividing by 3 because he has 3 scores that we're finding the average of. So first would be to add. You always have to do that part first, so that's why I put it in parentheses here when showing our work. So 55 plus 60 plus 35, you may need to write that out vertically so you can figure out the answer. So 5 plus 0 plus 5 would be 10. 1 plus 5 is 6, plus 6 is 12, plus 3 is 15. So the sum of the data is 150, and then you need to divide by 3. Well, 150 divided by 3, think of like 15 divided by 3. And then add that 0 on the end, your answer would be 50. So Sam's average score on the tests is a 50. Now range is the other thing we're going to talk about, another piece of statistical data. Range, by definition, is your highest data value minus your lowest data value. Well, that's how you find it. But really, what range is telling you is how spread apart your data is. Range can sometimes tell us how valid our mean might be. If our data is really spread apart, That means we've got some really high numbers, some really low numbers, and so maybe our mean, our average isn't like a really true representation of really what that person's average is. We can have what's called outliers, so like things that are really, really high or really, really low that mess up the data. So a small range means you have some pretty consistent data. A large range means you have data kind of all over the place. So for Sam, to get his range, we would want to pick out what's the highest, best test score he had, and his lowest, his worst test score. So out of those three, his highest would be 60, his lowest would be 35. So when you subtract 60 and 35, and again, you can always write it out vertically if you need to figure it out, you should get 25. Now that's pretty spread apart considering that his scores are 55, 60, and 35. To say that his highest to lowest is 25 points apart is pretty far apart because it looks like he had a bad test here, right? This is an outlier. Looks like normally he's really more in that 55 to 60 range, but something happened there. So that range helps us identify something like that. Think about your range is how far apart this lowest number and this highest number are on a number line. So they are 25 units apart. So his scores all fall within that 25 unit range on the number line. So let's look at some examples. Now, in this chapter, we would be looking at positive and negative numbers and finding the average and range of those, since that's what this chapter focuses on. You can think an example of finding an average that has negative numbers could be with the weather, so like with temperatures. When they find averages in January and February, I'm sure there are negative numbers that need to be added in there. Money, if you had a negative balance in your account, that would be a negative number that's getting added into your average. Some sports, like golf or football with the loss of yards, would be including negative numbers. So we have this data set here, -3, -8, 12, -15, and 9. We want to find the mean of that data set. Remember, step 1 is find the sum, and then step 2 is going to be to divide. Now when you go to find the sum remember means we're adding. You can add in any order you want, right? The commutative property of addition allows you to do that. I personally like to add all the negative numbers together and all the positive numbers together, and then add those two answers together, because same sign addition is easier than different sign addition. So I would go through like this and find all my negative numbers, and I'd figure out what those are. So I would do -3 plus -8 plus -15, and I'd add those together one at a time. Okay, so -3 and -8, same signs, means you just add and keep the sign the same. That'd be -11, and then -11 plus -15 would be -26. Then I'd add together my positive numbers. So I've got 12, 9. So 12 plus 9 is 21. Then I'd take these two numbers and add those two together. Okay, that's one way of adding them together, and I think a fairly easy way to add them together while still keeping track, making sure that you've included everything. So now these are different signs. So remember, with different signs, we subtract. So I would think 26 minus 21 is 5. And then the sign is used for the bigger air quotes number, the one with the bigger absolute value. So this one has a bigger absolute value. So that means -5 is my sum. I know that seems like a lot of work, and sometimes students make the mistake of being like, yay, that's my answer. But it's not, because all you've done right now is step 1. That's your sum, is -5. You still need to divide. What do I divide it by? Well, that number depends on how many numbers you have in your data set. You need to count them up. In this case, we have 1, 2, 3, 4, 5. So this time we divide by 5. If you remember, for Sam's test scores, we divided by 3 because he had 3 test scores. So remember, dividing different signs means your answer is negative. So our mean, our average, is -1. Part 2 says, what's the range of this data set? Remember, range is your highest value minus your lowest. It does have to be in that order. Remember, subtraction is not commutative, so I can't just flip-flop this around and do lowest minus highest. If you do that, you're going to get the wrong answer. You're going to get the opposite of the correct answer. So my highest value is 12 minus my lowest value is -15. So I've got 12 minus a -15. Remember, subtraction, leave, change, opposite. So leave 12 alone, change that subtraction sign to addition, change that -15 to a +15, we get 27, which makes sense because remember, range is supposed to tell us how far apart our data is. So in other words, from -15 on the left side of our number line to 12 on the right side of our number line, there's 27 numbers in between. If you mess this up and you don't do your subtraction rules right, you get something like 3 or -3. If you remember what range means, that hopefully wouldn't make sense to you. You know those numbers are more than 3 apart, and to say they're -3 apart doesn't even make sense. Your range should always be a positive answer because you're talking about how far apart the numbers are. So, another example for you guys to do, I'm going to give you a minute here to just pause so that you can try it on your own, and then I'll start talking in just a minute when you hopefully press play and are trying to figure out the answer. Okay, hopefully you paused and had some time to figure this out. So, what's the mean of the data set? Remember, first you want to add. I said I personally prefer to add all the same signs together first, so I'll just start with the positive number since that's what's first in my list this time. So 11 plus 10 would be 21. And then I've got all my negative numbers. So I've got -7 plus -14 plus -5 plus -7. You can add those together in any order you want, anything that you think might be easier for you. I'm just going to work from left to right. So that would be -21. And then if I do these two next, that would be -26. And then if I do these two, that's -33. So then remember, take your positive answer and your negative answer and add those two together, which really means we're going to subtract because they're different signs. So 33 minus 21 would be 12, and it would be -12 because the number with the bigger absolute value is negative. Remember, that's not your answer. Your mean's not -12. You still need to divide by however many pieces of data you had. 1, 2, 3, 4, 5, 6. So divide by 6. Different signs means our answer should be negative, so that's a -2 is the average. Now -2, maybe not really a great average here. Does that really seem close to a lot of your data? It's pretty close to -5. It's kind of close to -7. But a lot of those other pieces of data, 10, 11, 14, it's not really close to that. Why might that be? Well, let's look at our range. Your range is your highest minus your lowest. Your highest data value here is 11 minus your lowest data value is 14. So remember, do leave, change, opposite means your range is 25. That's pretty far apart, which is why our average doesn't seem super accurate. So if your average doesn't really seem to represent your data, it could be because you have a wide range in your data. That should prepare you guys for doing your Friday homework.